Their defeat was merely a delay. To the time after Oblivion opened, when the sons of Skyrim would spill their own blood. But no one wanted to believe they even existed. And when the truth finally dawns, it dawns in fire. But there's one they fear. In their tongue, he's Dovahkiin.
Skyrim is the fifth installment of the Elder Scrolls series. The game takes place in the province of Skyrim, and features a land filled with magic and dragons and lots of other stuff. Obviously, this isn't a game founded in science. However, I thought it'd be entertaining to figure out the science behind some of Skyrim's magic. So today, I'm going to be analyzing three different facets of Skyrim's magic. First of all, the unrelenting force shout, followed by the lightning bolt spell, and then finally the wards. So the first major thing I had to do was figure out a way to measure Skyrim. Unfortunately, the game is not very well tied to our reality. There aren't any good things that translate over as per measurements, so I had to take a bit of a stretch in my measurements. The average length of firewood is about 16 inches, or 40.64 centimeters. From that, I created a line of firewood, which would serve as my ruler in-game. Using that, I could estimate lengths as well as sizes of objects. The second thing I would need was a mass with which to measure. This one wouldn't be as hard as the first, since the game does contain elements from our reality, such as gold and iron. My choice was gold. Using the length of the wood, as well as the gold bar, I made some images and then used pixel measurements in order to determine the size of the gold bar. From there, I took the size of the gold in meters cubed and multiplied it by the density of the gold, or 19,300 kilograms per cubic meter. This would give us the mass of 4.94 kilograms, which would be used for the rest of the measurements. So, the first thing we were going to measure was the unrelenting force shout. But shouts in Skyrim require a bit of prefacing. To begin, each shout is composed of 3 words, and depending on how many words you say, the shout has different levels of intensity. Unrelenting Force is a shout designed to stagger enemies and eventually knock them back depending on the power of the shout. So you'd expect it to have a pretty good punch behind it. But as it seems, the first 2 levels of the shout don't even meet this expectation. My method for calculating the force of each shout was to shout at the gold bar in order to get its velocity by analyzing the recording afterwards. Then I would take that velocity and put it into 1/2 mv squared. From here, I could take that measurement and divide it by the distance traveled in order to gain the force of the shout. The numbers for each shout are as follows. So, the first 2 levels of the shout barely mark up to even a normal sneeze, which can range from around 6 to 9 newtons. However, as you can see, the 3rd level of the shout greatly outranks that. The average human lung capacity is about 6 liters, which means that the human lung can hold about 7 or so grams of air. Using this, you can calculate that you would have to exhale that air at about 26,000 meters per second, or about 80 times the speed of sound, which would probably end up ripping your lungs out, and also your throat. Not the most pleasant experience. But it gets worse. The next bit of magic we're going to analyze, the lightning spell, posed a bit of an issue. The gold bar ended up going incredibly fast. Like, I had to measure its traveling along the log ruler in terms of frames. In fact, one frame at 60 FPS. So that's a 60th of a second to travel the full distance of the log ruler. From here, we could do the same thing we did with the shout, calculating the velocity of the gold bar, which ended up to be about 292 meters per second. From here, we could do what we did with the shout, taking the velocity and putting it into the energy equation to get the energy of the bolt, and then putting that through the distance traveled to get the force of the bolt, which is about 40,000 newtons. We could also use these numbers to calculate the voltage of the bolt, but first we would need another number, the resistance of the column of air the bolt travels through. For this, I took the maximum range of the bolt, which is about 141 feet, or 42-ish meters, and then I put that into the equation R equals PL divided by A, where P is the resistance of the substance, L is the length that the substance goes, and A is the area of the substance. Our p-value for air is about 1.3 times 10 to the 16th. Multiplying that by the 42 meters and then dividing it by the circular area of the palm of a hand, I calculated the resistance to be 1.14 times 10 to the 21 ohms. To get to our voltage from here, I had to do a little bit of equation mixing. Voltage amperes, or voltage times amperage, is equivalent to the power of an object. Taking this equation and replacing the voltage in voltage amperes with amperage times resistance gives us the equation amperage is equivalent to the square root of power divided by resistance. Using this, we can calculate our amperage, which is 1.36 times 10 to the negative 8, and then we can multiply that by our resistance in order to get our voltage, which is a bit of a ridiculous number, 1.6 times 10 to the 13th. To put this into perspective, a normal lightning bolt is about 1 billion volts at maximum. This is 16 trillion volts. That's a lot of energy. Not something you want anywhere near the palm of your hand. The final part of this involves the numbers from the lightning experiment. In order to calculate the force output by wards, I had to take something of a conversion of newtons directly to damage. Each ward, depending on its strength, has a varying amount of health. The lightning bolt imparts the 40,000 newtons we talked about earlier, and deals about 25 damage as a result. From here, it was a simple matter of figuring out conversions between the ward's health and the damage, and then multiplying that by the 40,000 newtons that the lightning bolt puts out. The force outputted by the most basic of wards, a 40 health lesser ward, would be about 70,000 newtons, which, when applied to an average human of about 70 kilograms, would exert 100 Gs of force. The average human can survive about 20 Gs at maximum, so not a fun time, but that's the lowest, the least powerful ward. The highest ward has 80 health, but you can do a thing called dual casting, where you cast the spell with both hands, multiplying its effectiveness by 2.2, which means the highest ward effectively now has about 176 health. This puts the Newton output of the dual casted greater ward at about 300,000 newtons. This is 450 Gs of force, pushing out both at you and in front of you whenever you cast a ward spell. This should not be a defensive spell. It's really, really funny because wards are some of the most useless spells in game because they only block magic, and they aren't even very good at that. You know, this was a very entertaining experience to see just how big these numbers got and how ridiculous it was. I hope you all enjoyed the science of Skyrim.